In this video, we are going to tackle a very big subject in programming, particularly in the languages of C and C++, and that is memory pointers. Because in these older languages, you have direct access to variables that hold memory addresses, and they're called pointers. Pointers are very, very powerful. You can do a lot of different things with pointers. What we're going to do in the next, it's almost an hour-long video, is really look at what they are and the basic syntax for how to use them. Okay? We're going to do very basic functionality, and about 3/4 of the way through, I kind of set up a mistake because I want you to see it's where a lot of students make that mistake. And I just kind of let it happen, and I'm like, whoa! And then I go back and I fix it, and then I actually made a mistake because when I copied and pasted the text, it's still a little confusing. So I decided to leave that in because it forced me to explain where the text was wrong, and then I go over it in depth. So I'm just telling you ahead of time, part of it was set up and part of it was me just messing it up. But I liked it when I watched it in replay because it really makes you work through it. And you're going to make mistakes with pointers. So understanding how to kind of go back and say, okay, this is what I should have been looking at, and this is what I should have said in this print statement, I think it really does actually help. So sometimes I like to leave even my mistakes in, and even when I'm building on things that I wanted to be a slight got you and I turned it into something confusing, it's still worth it to see because it's kind of right at the place where a lot of kids make a lot of mistakes and a lot of programmers make mistakes. And so I want you to see it. So if it's too confusing, I'll edit it out and change that part of the video. But for now, I kind of want to leave it in and get some feedback and see what you guys think, because I think it's worth it to leave it in there. But it's one of those things where this is such a deep subject, I really want to see if it works. Okay? So I'm experimenting a little. And it's a long video, so you might want to take some notes. I definitely think you should code along with me, even when I lead you down that briar path, because the act of fixing what was wrong is a good exercise. Okay? And it really does bring into stark contrast the two different types of things we were trying to do at that point. I don't want to give away the thunder, so take a look at the video and I'll see you when it's over. Welcome to our coding discussion of pointers. Now, there are some college programs that don't get into pointers till your sophomore, junior, even senior year. Some professors are like me and they believe that you should understand these pretty early on. I tend to be in that camp. Pointers can be very, very confusing and difficult to understand if you don't walk into them correctly. If you do, however, and you get a solid introduction, I want to try to make the argument that they're really not that difficult if you really, from the beginning of your programming days, have a good sense of what they are and the purpose they serve. And that way, when you hear terms like dereferencing a pointer, you go, okay, well, they're just figuring out what it's pointing at. It's a lot easier to get your head wrapped around it. So we're going to walk through this. This is going to be a longer video because it's something that I need to take you through on a specific journey that I think will really help make them clearer. And you may come back to this video time and again to hear it again, and all of a sudden it'll click. Okay? And even then, you walk away from pointers for a while and you come back and you're like, oh, what was that? It helps. And this will lay some foundational understanding in your brain that will help you not just in AP principles, but in APCSA, when you get into Java and objects and things of that nature. If you understand what's happening in memory of a computer or the state of a computer, the sooner you start to get that settled in your mind, the easier a lot of this stuff gets. So pointers are not as difficult as people sometimes make them out, but you really need to kind of just crawl, walk, run into them. And I'm going to try to take you through that today. So the first thing we're going to talk about is variables. Okay? Because a variable is nothing more than a place in memory that has a location that's an address, that has a label that points to that memory address. Okay? And if you remember my index equals 4 discussion, okay, I'm saying go get 4 bytes of memory, have this variable called x point at it, so that when I say x, you know where to go to get that value out that I put on the other side of the assignment operator. Okay? So we're going to make 2 of those right now. The first one's going to be, and you'll notice I've already got my file set up because I want to save time. I'm just going to say int my number equals 12. And then I'm going to say char my initial equals R. Okay? Now, let's talk about that for a second. What I've done is I said, go get me an integer, which is 4 bytes, called my number, and put the value 12 in there, in that memory location. So somewhere, the compiler has created on the stack a table with the token my number, and it points to a memory address where the value 12 is stored. The exact same thing happens for a character, which is probably a byte, okay, named my initial, and it's stored a capital R there, which could either be the integer ASCII value or the character R, depending on how you interpret that value that's stored in that byte. Okay, that's all it is. All right, now I'm going to show you where those variables are stored. Now it's going to look different for everyone that has a computer because your instance of this Linux terminal is going to have a stack somewhere and your memory is going to look totally different than mine. It doesn't matter. We're just going to look at the memory address where these 2 variables happen to be stored. And that's all we're going to do. So I'm going to say we're going to print the address of these 2 variables. That's what we're going to do. Okay? So we're going to say printf. Now, you're going to see me duplicate a lot of what I'm saying here so that the printout, when we run this, is very easy to understand. So bear with me if I have a lot of print statements in here. But here we are printing the addresses of my number and my initial. Okay? And I got to remember my /n. And semicolon. And then what I'm going to do is printf. And I'm going to go old school and put a line. Okay, /n. Okay. Now there is a symbol that you're going to see me use in front of the variable name that says I want the address of this variable. I don't want the variable itself. I want the address. So here we go. We're going to say printf. And I'm going to say my number is stored at address. Oops, missing. The beautiful thing of colorization is you can tell by the color if you're doing it wrong. My number is stored at address colon. And here I need percent, this is a new one, P for pointer. Okay, and I need my /n. And then I need a comma. And the address of a variable is done by the ampersand, which is on top of the 7, the ampersand followed by the variable number, my number. Okay? And I want you to think of ampersand as address. So address, ampersand, address my number. Okay? And then I can literally copy this, Control C, Control V, and say my initial is stored at, and I'm going to put a space here just to line those up. And this is going to be my initial. Okay? Now, we're going to start with just this, where I want to know where in memory these things are being stored. Okay? That's what I want to know. So we're going to go over here, and we're going to say make point / point. And there we go. My number is stored at address hex 7FFF BD1CDO2C. Okay, and notice the next one is very similar O2B. So however it's, and I just want you to notice how this is represented. We don't care where that is. We just know it's stored on the stack somewhere. Okay, and so these are pointers. And notice it goes C and B. Those are just two memory addresses. Somewhere in the storage of this Linux terminal on the stack for this program, that's where they happen to be stored. But clearly that is not a value being stored, right? That is an address in memory. And that's going to be really important as we start to do other things, okay? So now we're going to go back over here and let's talk about what we're going to do next. We're going to make 2 pointer variables. Okay? We're just going to make 2 pointer variables, and we're going to talk about what a pointer variable is. All right? So first I'm going to say making 2 pointer variables. Okay? And the usage is data type space asterisk variable name. Okay? So when I make a pointer variable, okay, I'm going to declare the data type of what I'm going to point at. And I'm going to give it a name. Okay? And it's going to store as its value one of those memory addresses. So let's make 2, and we'll talk about them because that's the easiest way to do this. So we're going to say a float, and I'm going to literally name this float pointer, PTR. And I'm going to make a char pointer called car pointer. Actually, I think I used the full word, character pointer. Okay? And those are both now pointer variables. Okay? So there's a couple things we need to talk about. One, float pointer can only be used to point to a float. Character pointer can only be used to point at a character. The compiler should keep me honest for that. What they're going to store is a memory address of a float and a character. Now, I can move these things around. I can move the floating pointer to point at any one of millions of floats that I might be storing. And I can move the character pointer to point to any number of characters that I want. Okay? And what they're going to store is the address of the character or the float that I'm pointing at. They're not going to store the value. They're going to store the address. So if I want to know what's the value, then I need to dereference the pointer, which means I need to follow the pointer in and go get the value at that memory address. Okay? So these variables are going to store memory addresses, not the values at the memory addresses. Okay? And we're going to show you this as we go, and I'll try to say it several times. Now, the first thing I'm going to do is I'm going to show you the addresses of these pointers, because these pointers are also variables on the stack, and they have an address just like my number and my initial. Okay, so I'm going to print the addresses of those two variables. To do that, I'm going to steal all of this, because by doing that, you're going to see that it's the same stuff of these two, and I'm going to call these pointer variables. Printing the address of, and this is float pointer and character pointer. And I'll need a couple more of these. And I'm going to say float pointer is stored at address, and this is going to be ampersand, or the at of float pointer. And you're going to see why this is so important in a minute. It's going to help make it a lot easier. Character pointer, and let me make this say character pointer. Okay, because these are variables. These are variables just like these are variables, and they have addresses on the stack. Okay, so let's see if we got this right. Make point dot slash point. Okay, I could use some space in there, but notice they're kind of in the same general area, aren't they? It's the same all the way through 6A, 8A. So you can tell that my stack is very close in memory, right? And that makes sense. So one of the things I'm going to do is in here, I'm going to put printf vertical tab. Give us some breathing room. Okay. And let's just pull that in real quick. Because I want it to be really easy to read. Okay, so the addresses of my number and my initial are there. The address of float pointer and character pointer are there. And they're all clearly on the stack. Okay, they're very closely tied together because they're the only four variables in this program. It's a very small stack. Okay, and I've got an int, a char, a float, and a char. Okay? And all I've showed is the stack, right, in memory. I'm showing you where those variables are stored. Haven't done anything with the pointers yet. Okay? But they're variables, and so they have an address, which we can see by using the ampersand. Okay? Now, I'm going to make 2 more variables that have distinct values that happen to be the same type as my pointers. Okay? I did this as an early example. I'm going to use a float and a char now because we're going to start playing with these. So I'm going to make a new float called my grade, and it's going to equal 96.4. Okay, and I'm going to make a char, which is my letter grade. Notice the camel case, equals, and capital A. Okay, got an A in the class. All right. Now, before I get to that, there's one more thing I want to show you that I think will actually be helpful. I want to show you the values that are being held by these 2 pointers. Okay? Because we created these, but we didn't assign anything to them. Okay? So I want to show you what is being done there. So I'm going to kind of steal this to save me some typing. And I'm going to say print the values held by these 2 pointer variables. Okay? So this is printing the values held by float pointer and character pointer. Okay, give it a couple more lines. And we're going to need another vertical tab. Okay, and what I want to put in here is float point holds the value. Now it's still going to print out a memory address, but I don't want to know the address of float pointer. Now I want to know what is the actual memory address that it's holding. And I'm going to talk about this for a minute while we look at the source code, because the addresses here, by using the ampersand, show us where on the stack these pointer variables are being stored. Now, they've been declared, but they haven't been initialized. So the system's going to kind of give them an initial value. Okay? And we want to know what that value is. Now, because it's a pointer, it's going to be a memory address, or it's going to be null, because it's either pointing somewhere in memory or it's pointing to nothing. Okay? So let's do Control Save. And these should be memory addresses that are not near the stack. Okay? So we've made it. Let's do a clear, and we'll do /point. Okay, notice the memory addresses are still somewhere on the stack, but notice float pointer holds the value 0x400730, somewhere completely different, and character pointer holds nil. Or null. It's pointing to nothing. Okay? So they're not really pointing anywhere. This is dangerous. Because if I dereference this could be pointing at somewhere at video memory. It could be pointing at some part of the operating system that the memory has now been freed up. So I don't want to just go accessing these or I could seriously blow up my code or my operating system. I don't know where this is in memory. So you do not want to just go jumping around memory. This one, fortunately, the system gives me a nil or a null. Okay? So it is a good idea when you do this to make these equal to null. Now, I don't want to run null pointer errors either, but let's see what happens. Now I get nil nil. So I've gotten rid of that ghost garbage memory address that could be somewhere dangerous, and I've made sure that they're both pointing to null. Okay. Now if I try to access a value at null by dereferencing it, it's going to go, what are you, crazy? It's not pointing at anything. Okay, and it's going to throw a null pointer error. But you really want to initialize those to null. Okay? So now you've seen that any old variable has an address. Well, pointers are just another type of any old variable. They just happen to have memory addresses as what they store. Okay? But they have a location on the stack too, because it's a built-in data type. So int, char, float pointer, and char pointer are all built-in variables stored on the stack. And I can look at where are they stored themselves. Okay? But what is stored in a pointer, unlike these two where it's a literal 12 and an R, in these pointers, what is stored is memory addresses. Okay? Now, the next thing I'm going to do is I am going to print I think I'm going to do I'll do these together. I'm going to print the address of my grade and my letter grade like I did up here. Then I'm going to point these two variables at these and then show you that they point to the same place. Because like I said, I can repoint these. So I'm going to point them at these, show you that the memory locations are the same, and then instead of using my grade or my letter grade, I'm going to use the pointers to go in and reference these values. Okay? So let's kind of do this in steps so that we can see what we're doing. So the first thing I'm going to do is print locations of variables, my grade and my letter grade. That's what I'm going to do first, which is exactly what I did up here. But I'm going to do it for these two. Okay, so this is going to be my grade and my letter grade. And then I'm going to say my grade and my letter grade is stored at address, and this is going to be at my grade and my letter grade. Okay? Now bear with me because I want to show you this in steps. So we're going to do a couple extra make builds here, but it's going to be worth it. Okay, so now down here, I've got my two nils. I should have had another vertical tab in there. But printing the address of my grade and my letter grade, notice I'm back on the stack. The stack has moved each time I run it, right? But here the stack is 773A4 and 773A3. So right next to each other are these two variables. They are on the stack at these memory locations, okay? That's where these variables are stored, okay? So let's do a clear here. And I'm going to go back here and put a vertical tab. Control C. I might put 2 here. All right, so what I've done is I've shown that on the stack, these two variables have a position. So what I'm going to now do is I'm going to repoint float pointer and character pointer at the variables. Now I know how to get it where those are. It's just using the ampersand. So I'm going to say float pointer equals ampersand migrade. And I'm going to say character pointer equals ampersand my letter grade. And what I've done is I've said, and I'm going to say this is repointing my pointer variables. So that means storing new memory locations as new values for each variable. Okay? I'm basically putting new values. It's like saying x equals 4 and then saying x now equals 22. I'm putting different memory addresses into them. And by the way, I had initialized those now to null. So they should go from nil to being the exact same memory address of these. So to test that, I'm going to say that I am printing the address of two variables, but they're going to be of repointed pointer variables. Okay, so this is now the new addresses of float pointer and character pointer. And this is going to be float pointer. And this is going to be at float pointer, because I want to make sure, and this is going to be character pointer, because I want to make sure that I'm verifying the fact that I have my pointers restored and the values I see here should be the exact same memory location of these two, because I have pointed my pointers at the location of those two variables. Okay, so I'm going to go over here. I'm going to say make. I'm going to say run it. Okay, and the letters of my grade and my letter grade are there, and the new addresses of float pointer and character pointer. Oh, so what did I do wrong? These are not the new addresses stored in float pointer and character pointer. I don't want where these variables are stored. I want the actual value in them. Okay? That's the difference there. And that right there is one of the #1 mistakes that people make. It's really easy to do. So I'm going to say this again because what I want you to see is that I have pointed these variables, these two variables, at these memory locations. Okay? If I dereference these with the ampersand, what I'm saying is, where are these two variables stored? That's not what I want to know. I want to know what are the values stored in here, because that's what they're pointing at. So I don't want the ampersands when I'm looking to see is the values of where these are pointing at the same location of these grade variables, because these variables are not pointers. They are basically memory well, they're pointers, but not in the sense of pointer variables. They're pointing to a memory location, which I know here. So the values stored in my pointers should be the same location of the variables. I'm going to say that again. The values stored in the pointer, not where the pointer's stored. The values stored in the pointer should be the same as the location of these variables. Because when I say store the memory location in here, that's the value of this, not the location of those variables. So now, when I go in here, it'll be set to run correctly. Make point ./point. And now you will notice that the addresses of my grade and my letter grade are correct, and this is the value. So this print statement is wrong, right? Because I copied and pasted it. This is print the values of memory stored in the pointer variables. Okay? I'm printing the values of memory stored in the pointer variables, which should be the same location as my grade and my letter grade. Okay? So this is printing the new values stored in float pointer, and now we have a full correct printout that you'll be able to follow. There we go. So the address of my grade and letter grade, my letter grade, are CD04 and CD03. I reassigned float pointer and character pointer so that now, and you know what? I'm still going to change this because they're not stored. That's still wrong. This is one of the problems with copy and paste, and I don't want to be confusing here. Float pointer holds the address value of, and character pointer holds the address value of. Now we're saying it completely correctly, and that one's on me. Make point ./point. Okay. So we have float pointer and character pointer at nil. We have stored on the stack two regular variables that we made at these locations. We repointed float pointer and character pointer at these variable locations. And we verify it because they are pointers, so they hold a memory address. And sure enough, 6954, 6953, 6954, 6953. So float pointer is holding the address value of my grade, because this is where my grade is stored, and float pointer is now pointing at it. And my letter grade is stored at 6953, and character pointer now holds that as its value. Okay, so I can use the variable my grade to go get that value. Or I can use float pointer via the memory address that it holds to also go get that value. I can use my letter grade just by referencing this to go get that value. Or I can use character pointer via the value it holds to go get the value as well. Okay? And that is what we're going to do as the final step. Okay? So, the way we're going to do that is we're going to show that these pointers are pointing at the correct values that we have stored in these variables. Okay? So, I'm going to just do this old school so that I don't have any more copying and pasting errors. We're going to say showing that the pointer variables correctly point at variable values we can go get. Okay? And I'm going to say print f note the values are correct from the original variable assignments. Okay? And oh, let's not forget a /n. And my semicolon. And I am going to steal this one. Control-C. And do a Control-V. Give it a few more. So it's nice and pretty. Now, for this, we are going to dereference the pointer. And let's get these lined up. I don't know why I have an extra space in there. All right, so we're going to say printf value stored that is pointed at by float pointer is space. Now this is %, it's a float, /n, quote, comma. Now here is where we're going to, oh, missing the open. There we go. The value we're going to put here is I can't just put float pointer or it's going to give me the memory address held by float pointer. I can't put ampersand float pointer because that's going to give me the memory address where float pointer is stored on the stack. So I need to dereference, so I go pointing at by float pointer. So this means, this asterisk in front of it means, what is it pointing at? What's the value it's pointing at? Okay? And that's what I want there. Okay? Now I'm going to copy this one, Control-C, Control-V, and say the value stored is pointing by character pointer is, and I'm going to line these up a little, and this is going to be character pointer. Okay? Because these should now, what I should see here is 96.4 and A. Okay? And and I also need to make sure that since I copied that, I'm using character. Okay? because I don't want to see the ASCII value there. All right, and let's see, note the values are correct. Value stored that is pointed at. Okay, so I think I have my verbiage right this time. So let's clear, make point, ./point. Okay, now if you look at this, you will notice that I got 96.4, and we're going to talk about this in a minute, and the letter A. Okay, so I want to walk through what we've done from the top, but you notice that I'm getting, and we've talked about this in some of the earlier videos, I'm beginning to see some introduction of error because I used a float. And so because it's dereferencing the variable, it's giving me 1, 2, 3, 4, 5, 6 bits of accuracy, but it's got an extra 0.000002 in there that doesn't belong. So you need to be cognizant when you use floating points in C about the precision that you need, and you need to look at stuff like this to make sure that stuff's not creeping in on you. Okay, these older languages, this is a factor. Okay, so this is looking at the raw memory, and that's what got stored. The variable that's there when I assigned it was clearly, let's go to the source code, 96.4. But there was some noise introduced because that was a float. Okay, so maybe that needs to be a double or a long double. Okay, but here's what we did. We're going to start from the very top because I want you to have this clear in your head. We created two variables, and we showed that we can look at the address of where they're stored. That's all we did. Then we created two pointer variables, which are just another kind of variable. And all we do is we tell what they're going to point at, because the compiler needs to know that. And we put this asterisk in front of them and say, all right, we're going to name this one float pointer and character pointer, and to be safe, they're going to point at nothing. Okay? And then what we did was we printed where those variables were stored. Okay? And then we printed what are the values that they're storing, and when we fixed this to null, we saw that those became null. So when we have the ampersand, we're asking, where is this variable on the stack? Where is it at? Where is that variable physically stored in memory? When we just put float pointer and character pointer, okay, we're saying what is the memory address stored in that pointer variable? So this isn't a well, it's a value, but it's a memory address value in both of these. Even though the one points to a float, one points to a character, these are memory address values in these variables. So then we created two other variables, and we kind of, for comparison reasons, needed to know where they were stored on the stack. Because what we did was we repointed our pointer variables to those locations. So now my grade is stored at a certain place in memory, and float pointer is pointing right there. And my letter grade is pointing somewhere in memory, and character pointer is now pointing right at that as well. So we needed to show that these were really pointing at those. But the first time we did it, we left the ampersands in, and it didn't work because we forgot that we don't care about where they're stored on the stack. We care about where are they pointing. So we want the value of that variable, because those are memory addresses that should now be equal to that. So we saw that you don't want to leave those ampersands in when you want to know what's it pointing at. Okay, so float pointer and character pointer are now the same value as at my grade and at my letter grade. And then what we did to prove further, because we actually looked at these two memory address sets and they were identical, but we went and we dereferenced those pointers by looking at, hey, what's it actually pointing at? Hey, what's the value it's pointing at? And we got them, and we even noticed that there was some noise introduced into float pointer. So that's pretty cool. So let's look at it one more time. And walk through it from this side. So the first thing we did was we created a couple variables and they had memory addresses. Then we created float pointer and character pointer and they had memory addresses on the stack. And notice they're pretty close to the other two variables. But then we initialized them to null and we checked what's the value in them. Okay? Then we created two variables that are the same type as our pointers, and we put them on the stack. And notice they're pretty close to everything else we've created on the stack. Okay? But these are the memory addresses of the values that we put in here. Okay? Because these hold values, these two memory addresses. So what we did was, rather than leave these pointers at nil, we pointed them at the addresses stored in my grade. Now, the first time we printed it out, we left the ampersand, and we were getting these values incorrectly because we forgot to take off the ampersands and say we actually want the value, the address value, stored by pointer and character pointer. So now, when we did that correctly, we see, yep, sure enough, this is my grade, and float pointer is pointing right at it. And this is my letter grade, and yep, character pointer is pointing right at it. So then we printed out dereferencing the pointer, and we got our 96.4, noticed some noise being introduced, and we got our character A. Okay? So when we look at our code, when we use ampersand, we're asking for where on the stack is the variable stored. When we just ask for the value, like if I just printed out my number, I get 12. If I printed out my initial, I get R. If I print out float pointer up here, I get null. If I print out character pointer, I get null. Once I point them to a different location, I should get as a value, which means not the ampersand, not where is this on the stack, but what's the value they hold. The value they hold should now be these memory addresses, which it was. And then when I say, okay, I know where these are stored on the stack, I don't care about that. And I know that they're pointing where these are on the stack, and I don't care about that. I just want to know what's the value out there. I just put the asterisk back in front of it, and it goes down that pointer and brings me the value. So in this case, star float pointer is the same thing as saying my grade. And star character pointer is the same thing as saying my letter grade. Because both the direct variable and the pointers that have been assigned to that location both point to the same thing. Now, I know that that is a lot. You may need to watch this video a couple times to really get this. I encourage you to either download the source code that I will make available or code this along with me, even if you have to hit pause 100 times, so that you really, really understand it. Okay? Pointers are a very important piece of coding in C, and you'll use them in C++ as well. When you leave those languages and you go to Java or C sharp or F sharp, you're now in what's called managed code, and you no longer have direct access to memory pointers. Because memory pointers are dangerous, and that's why most hacking is done in the language C and C++, because you can directly jump at areas of memory to do bad things. So hopefully this is going to begin to help with the confusion. I purposely went down one error trail because one, I think it'll make you think, and it is a very common mistake. It's one that I've made 100 times, and that is leaving the ampersands in and not realizing that I want the value held, not the pointer itself. So hopefully that detour I took doesn't add to your confusion, but if you play this back a couple times, I think it will help you lock in not to make that mistake. And that's one that I've seen made a lot. So I took the risk of leaving that in. And then, of course, I made it worse by not updating my text correctly. So that part's on me. But hopefully this will really get you into pointers a little bit. And I may do some videos later on, kind of in the bonus section for this playlist as we go through the year, that do more with pointers. But I think this is a really good basic introduction to where they're stored, what they hold, and how to get at the values they're pointing to. Wow, that was a lot. Congratulations for making it through the video on pointers. If your head hurts, you're normal, okay? Pointers can be very, very intense the first few times you go through them, okay? Again, go through it, give yourself some time to think about something else, maybe watch it again, watch it 3 or 4 times till you get it, but eventually it really does sink in, and it makes your life a lot easier if you understand them now, especially if you go on to become a computer science major in college, because you're going to do a lot in C++, building data structures, and you're going to use pointers. So if you understand what they are, what they hold, and what they point at now, it's going to really help you in the future. In the next videos, we're going to get into some specifics of individual libraries. We've covered enough of the basics for an advanced course that you should now be able to go out and find anything else you need for the language, or in the CS50 libraries, you should be able to find what it is you need to include in your code. However, one of the topics we're going to take on next is the CS50 library and some of the very convenient things that it provides us, including a very easy way to get user input into our program. While the user is running our program, they can provide us with data that we can then manipulate. So that's going to be in the next video. And then we're going to have a series of videos that talk about some library specifics as we go. So I'll see you on the other side.